Hello friends, welcome back to NPTEL online certification course entitled Soil and Water Conservation Engineering. I am Rajendra Singh, Professor in Agriculture and Food Engineering Department of IIT Kharagpur, and we are in lecture 3 of week 1, and today's topic will be factors affecting soil erosion and effects of soil erosion. Just to remind you of the course content of this week, in lecture 1 we started with introduction. In lecture 2 we covered causes and types of soil erosion. In today's lecture we will discuss factors affecting soil erosion and effects of soil erosion, and the following lecture will be where we will discuss about soil erosion mechanics, and lecture 5 of this week we will go into the control measures that could be adopted to tackle water erosion. So, let us begin with factors affecting soil erosion and effects of soil erosion. Factors affecting soil erosion. The factors affecting soil erosion can be summarized in a very simpler fashion as follows. Soil erosion is a function of C, T, V, S, C, T, V, S, where C stands for climate, T for topography, V for vegetation, and S for soil. So, it is very easy way of remembering the factors that affect soil erosion. Remember, soil erosion is a function of C, T, V, S. C stands for climate, T for topography, V for vegetation, and S for soil. And then in the subsequent slides, we will one after the other see how these factors affect soil erosion. So, let us start with climatic factors, and the climatic factors that impact the or affect the soil erosion are rainfall, wind, humidity, and solar radiation. These are the 4 climatic factors that affect the soil erosion. Now, we start with rainfall. Rainfall is the primary cause of raindrop splash erosion, and raindrops detach soil particles while runoff transports the detached soil particles. Remember, in our previous class, while classifying the water erosion, we saw the raindrop splash erosion is the first level of water erosion, and there we discuss that when raindrops occur, raindrops hit the bare soil particles, because of their velocity or because of their kinetic energy, they disaggregate the soil particles, and as a result soil particles get splashed. And obviously, that splash means that there will be detached soil particles all around the surface wherever rainfall is occurring or wherever raindrop impact has taken place. We also discussed further that when rainfall occurs, it first satisfies the infiltration capacity of the soil, and after satisfying the infiltration capacity of soil, if rainfall still continues, then it gets converted into overland flow. That means, the overland flow phenomena starts, and that is basically nothing but runoff, and that once the loose or detached soil particles are there on the surface, then runoff will transport the detached soil particles. That means, the entire soil and soil erosion process will be there. You remember, we defined soil erosion as detachment and transportation of soil particles. So, here we see that raindrops detach soil particles and runoff transports the detached soil particles. So, detachment and transportation of soil particles both occur, and that is primarily the factor responsible for that is rainfall. Then amount and rate of soil erosion primarily depends on amount, intensity, frequency and duration of rainfall. As you can logically think, if the intensity of rainfall is more, that means the rain storm event or rainfall event will satisfy the infiltration capacity of soil much faster, and then excess rain will be converted into overland flow. Similarly, if the amount of rainfall is more, then also the same phenomenon will occur, that the rainfall infiltration capacity of the soil will be quickly satisfied and the excess amount of rainfall will get converted into overland flow. If the frequency of rainfall is more, then also if today rainfall occurs, then of course soil will be moist, and suppose again tomorrow rainfall occurs, then because the infiltration capacity of the soil, or even if it is reduced, it will be requirement will be very less to satisfy the infiltration capacity, and that is why when the frequency is more, then also the overland flow process will be much faster. And same process is true with the duration of the rainfall. If rainfall continues for a longer period of time, then obviously the infiltration capacity of capacity of the soil will be satisfied very quickly, and for remainder of the duration period, whatever rainfall occurs, that will get converted into runoff, and that simply means that runoff will transport the detached soil particles. And when both amount and intensity are high in a given storm, erosion will be serious. So, we just now saw independently how amount and intensity could result in soil erosion, but you can easily guess that when in a given storm, rainfall storm, if both amount and intensity are high, then obviously it will very quickly satisfy the infiltration capacity of the soil, and that means the amount of runoff or overland flow will be severe, or it will be much larger, and obviously the erosive capacity or the capacity to transport the detached soil particles of such a event will also be very, very high. Now, continuing with the rainfall, frequent rains maintain a high soil moisture content and low intake capacity, which increases runoff and thus soil erosion. Just now we discussed the frequency. So, obviously, the same thing is here. If the frequent rainfalls occur, then obviously the soil moisture content will be at a very high capacity, and that means the infiltration capacity or the intake capacity of the soil will be very, very low, and in such a case runoff will be very high, and that means the erosive capacity of the overland flow or the runoff, that will be much higher, and thus soil erosion will be increasing, or it will increase, or it will be much higher. And continuing with this, rainfall soil topography combination also governs soil erosion, which is quite logical. So, if you look at a kind of a hilly terrain like this, then typically on this portion there will be more of rocks or stones, that means the soil quality will be poor, and of course, the slope will be steeper. And in that case, because the soil quality is poor, the infiltration capacity will be much lower, that means very little rainfall will get infiltrated, and that simply means that more of the rainfall will get converted into runoff, as we have seen in all processes, and that means the topsoil will be eroded fast from this portion. If we go certain down along the slope, then we will reach a place where the soils are average and the slope becomes gentle. Here the soils were poor and slope was steep, here soils are average and slope is gentle, and that simply means there will be some infiltration taking place in here, and that simply means that amount of runoff that is generated from the rainfall occurring over this portion will be much less, and thus the erosion of the topsoil will be much lower. But if we reach the belly bottom of the slope, that is this portion, where we can see that lot of plantation and grasses are also there, then that place which is expected the soil will be of good quality and the land is flat in nature, which simply means that infiltration of capacity of the soil will be more. That means soil will be more, that means there will be much lesser overland flow, much lesser runoff getting generated. Also, because there are vegetation here, so whatever soil gets eroded and get transported, that will be arrested by the vegetation cover here, and that means most of the soil will get deposited at this point of place. Then next is wind characteristics. If we look the wind characteristics, then obviously wind speed governs the extent of soil erosion by wind. We saw in previous class, we discussed that when wind is light, then it rolls the soil particles, but if wind speed is greater, then there is a dust storm. So, basically wind speed governs the extent of soil erosion by wind. Also, it affects the erosion by water, because the wind characteristics, they can influence the raindrop velocity and angle of impact. That simply means that generally, typically if soil surface is like this and raindrop is falling vertically, but in case there is a wind blowing, then obviously that will change the angle of impact, and changing the angle of impact of the rainfall obviously will have a different raindrop, result in different raindrop impact and a different kind of erosion. Wind also influences the evaporation and transpiration, and thus affects the soil water regime of the area, because if the wind is more, then evaporation and transpiration will be more. That means the water requirement to fill the soil reservoir or the soil moisture or infiltration capacity, that will be more. That means in that case overland flow will be less and erosion will be less. So, depending upon wind speed on one side could increase the erosion, but on the other side, because of indirect effect on evaporation transpiration, it could also result in decreased erosion. So, there is a trade off or there is a balance one has to analyze. Then of course, humidity and solar radiation, they also influence temperature and thus have indirect effect on erosion. And as we know that India is close to equator, somewhere here as you can see. So, obviously radiation is high throughout the year and it is in the range of 150 to 200 watts per square meter. And temperature also, like wind, impacts evaporation and transpiration phenomena and affects the soil water regime of the area, especially long dry spells. So, if there are long dry spells, then there can be two possibilities. One is the soil moisture will be less. So, whenever rainfall occurs, the more amount of water will be required to fill the soil water regime. But on the other hand, if the soil is very dry, then also there could be loose soil particles on the surface. So, if wind is there or even lighter rain is there, that will have a tendency to take away these lighter soil particles or loose soil particles that are lying on the surface. Then comes the soil properties. Properties like texture, structure and organic matter content influence the detachment and transportation of soil particles, and as a general rule, soil detachability increases as the soil particle increases, but transportability decreases with the increase in soil particle size. That simply means that if the size of particle is more, they can be easily detached. For example, if there is a sand particle, sand is there, it can be easily detached. But the same soil particle, because its size is more, so the transportation will be much difficult in this case. And soil containing high percentage of sand and silt are more susceptible to detachment. That is the reason that detachability is more, as they lack cohesive characteristics. continuing in the soil properties is the clay and organic matter content of soil increase, the erodibility decreases because of the simple reason that organic matters increase the binding capacity of soil. That means, soil aggregate is bound tightly, and that means the soil drop impact, much higher raindrop impact will be required for breaking down that kind of soil aggregate where the organic matter content is high. However, clays have a tendency to resist erosion. Once detached, they are easily transported. That is simply because of the size, that because we have already seen that detachability is less for smaller particles, but transportability is more for such kind of particles. So, because clay is smaller in size, so detachability is difficult, but it can be easily transported. The next factor is topography, and degree and length of slope are the main topographic factors that influence the erosion. And degree of slope is the dominant factor that affects the erosion, and because of the simple reason that if slope is more, then obviously the velocity of flow will be more, and the velocity of flow is more means kinetic energy of the flowing water will be more. That means it will have much higher erosive capacity, and same thing is written here. As the slope increases, the kinetic energy and the carrying capacity of surface runoff increases, thereby decreasing the soil stability. That means, erosion will be more in such cases. And slope length influences the volume and the speed of runoff. Of course, that is also a factor, that it is not only the magnitude. I mean, we are talking about two things. One is, say this is theta. So, this is slope and this is length. So, we are talking about two different things, slope and length. So, we saw already slope, and now we are talking about slope length. It influences the volume and the speed of runoff. Obviously, if the slope length is longer, then that means the much more of flow will get aggregated, and capacity of runoff will be higher, and that means more soil will be transported. Similarly, for soil worthy initiation, a critical slope length is needed. That means, a minimum slope length is required for initiating the soil erosion, and of course, it is also related to critical land inclination. That means, combination of slope and length, that is theta and length, that are responsible. Lower the critical inclination, larger will be the critical slope length. So, obviously, if we are talking about two soils, two land slopes, one is much flatter and one is much steeper. So, here a very smaller length will be required for initiating the slope, wherein here much larger length will be required. Now, the next factor we are talking about is vegetation, and as we know that a good vegetative cover impacts soil erosion in many ways, like plant canopies influence interception, that we have already seen, ground cover absorbs raindrop impact, and root system provides binding effects. Since yesterday we have discussing that plant canopy is very important. So, if we look in this diagram, then every component we can discuss one by one. So, obviously, if we talk about the plant canopy, it absorbs the energy of the falling raindrop, and also it intercepts the rainfall. If we talk about the ground cover here, then it protects the soil, that means it absorbs the kinetic energy. If we talk about the vegetation that are growing here, they help in maintaining absorptive capacity and slow down when the velocity of flow is there, then they will slow down the flow velocity, that means they will filter as catchment sediment. If we talk about grass roots, they protect the surface soil. If we talk about the deep roots, they help stabilize the soil particles. Same thing is true with the sub roots, they hold the soil particles, that means the aggregates are hold together and they are difficult to detach, and of course, from the plant surface, evapotranspiration takes place, which removes water from the soil. That means the soil reserve will be empty, and that means more amount of rainfall will be absorbed by the soil. That means the resulting runoff will be less, and that means the erosive capacity of water will be less in that case. Now, coming to ill effects of soil erosion, we have seen that what are the factors that impact. Now, what are the ill effects of soil erosion? Now, first one is that of course, we lose the top fertile soil, which impacts the crop productivity and crop production. We have already seen that after the raindrop impact, the sheet erosion starts, and that takes away the top fertile soils away, and obviously that will have impact negative impact on crop production and crop productivity. Then these soil particles which are carried down, they get deposited into the rivers and streams, and that simply means that if they get deposited in rivers and streams, the carrying capacity of these rivers and streams will be reduced, and that simply means there will be more chance of flooding, because the capacity will be less. That means whenever flow occurs, the banks will be overtopped, and that means there will be flooding all around. Similarly, if the silted water reaches the reservoirs and other storage facilities, for example, the tanks or ponds, then obviously because of the silt being carried with the water, it will reduce the storage capacity of the reservoir or the pond, and obviously it will reduce the life of the structure also. That means, if a reservoir was supposed to last for 50 years, then it will be lasting for much lower. Similarly, if a pond which was designed to last for 10 years, then because of siltation its capacity will go down, and that means it will not be able to store the required amount of water for which it was planned. Then in different countries, this is just a data presented by Morgan in 2005, that different what are the erosion rates in different countries in tons per hectare per year. We will focus on India. So, if you look at India, the geological erosion rate is 0.5 to 5 tons per hectare per year. The cultivated soils result in 0.3 to 40 tons per hectare per year, and the bare soil, they result in the highest, that is 10 to 125. That simply shows that we should be careful about the bare soil. We should cover our wherever bare soil is there, we should plant grasses so that soil erosion could be arrested. Continuing with the ill effect of soil erosion, then obviously land degradations due to soil erosion all over the country. This is the data presented in a recent work by Kumar in 2017, and as you can see, most of the places you find yellow color, which represents low to medium degradation of the soil, and obviously at certain places red colors are there. For example, here you see red colors, that means these are severely degraded soils. So, I mean soil degradation everywhere, and that means we have to be very careful about the problem of soil erosion. Then major land degradation problems due to soil erosion are erosion by wind, wind and water, waterlogging, soil salinity, and shifting cultivation. So, these are the major land degradation problems, and we will see each one of them one by one. Erosion by wind and water, if we look at, then we already saw a statistics yesterday that in India, out of the total geographical area of 328 million hectares, around 147 million hectares is impacted by erosion, various forms of erosion. And out of these 147 million hectares area affected by water and wind erosion, about 69 million hectares is in critical stage and needs immediate attention. That simply means that now we know that yesterday we saw that 147 out of 328 million hectares was impacted by erosion, various kinds of erosion problems, but now we also have another statistics that it is the 69 million hectares of area where we should focus, because they are in critical stages of erosion. And then wind erosion, if we look, it is mainly restricted to states of Rajasthan, Gujarat and Haryana, and severity of wind erosion is inversely related to the rainfall amount. Lesser is the rainfall, more would be the wind erosion, and that you can link from here also. If you see the states here, rainfall, Rajasthan, Gujarat, Haryana, the amount, especially Rajasthan and Gujarat, the amount of rainfall is little, and as a result the wind erosion is more prevalent in those states. If we look at some of the data provided by some of the researchers over the period of time, that is soil loss by water erosion given by Maji and others in 2008, then we see that most of the India we see yellow and greenish color, which represents moderate, that is 10 to 15 tons per hectare of year, or moderately severe, that is 15 to 20 tons per hectare per year. That is the soil loss by water erosion, that is the statistics. Some places it is extremely severe, that is greater than 60 tons per hectare per year, but those red patches are very limited. So, but most of the area as you see falls under yellow to green, that is moderate to moderately severe, that is 10 to 15 or 15 to 20 tons per hectare per year. On the other hand, if we look at the wind erosion data given by National Bureau of Soil Science and Land Use Planning in 2008, we find that most of the problems are in the state of Rajasthan and some portion of Gujarat, that is the places which are more affected by wind erosion. Now, coming to gullies and ravines. If you talk about gullies and ravines, about 4 million hectares in the country is affected by the problems of gullies and ravines. Gullies already, we have already discussed what are gullies. Yesterday we saw the gully erosion, and then we know what is gully, and they are found in plateau region of eastern India, foothills of Himalayas and areas of Deccan Plateau, wherein the ravines, which are defined as a valley with steep sides much larger than the gully, that means even further advanced stage of ravines, and when that level comes, we call them almost wasteland, because no agricultural activity can be taken up there. So, when ravines are mostly located in states of Uttar Pradesh, Madhya Pradesh, especially Bundelkhand here, Madhya Pradesh, Rajasthan and Gujarat. If we talk about the waterlogging, then waterlogging is caused either by surface flooding or due to rise of water table. So, both possibilities are there. Surface flooding, basically if you irrigate too much and there is no drainage facility, or if you again irrigate too much and that most of the water goes into groundwater, reaches the groundwater, and if there is no pumping, then the groundwater table itself will come up, and that causes waterlogging. And in India, around 8.53 million hectares is affected by waterlogging, and due to surface flooding is predominant in the states of West Bengal, Assam, Bihar, Orissa, Andhra Pradesh, Uttar Pradesh, Kerala, Punjab and Haryana. So, that means you can see almost all the major states of India are having ill effect of waterlogging or ill effect of soil erosion in the form of waterlogging. Then, if you talk about the soil salinity, then saline soils are prevalent both in inland and in coastal areas, because of the salt water intrusion in the coastal areas and because too much salt in the soil, that means poor irrigation management in the inlands. And overall about 5.5 million hectare area is affected by this problem in the country. which includes arid and semi-arid areas of Rajasthan and Gujarat, black soil regions and coastal areas. And lastly, we talk about the problem of shifting cultivation. This shifting cultivation, which is also referred to as zooming, is a traditional method of growing crop on hill slopes by slash and burn method. So, there are three different names: shifting cultivation, zooming and slash and burn method. So, same cultivation technique could be known by three different methods, and the method involves selection of appropriate site on hill slopes, cleaning of forest by cutting and burning, using the site for cultivation for a few years and later on abandoning it and moving to a fresh site. And this problem is more prevalent or more serious in the northeastern region and the states of Orissa and Andhra Pradesh. That means, there are certain tribes which resort to shifting cultivation of or zooming or slash and burn method of space. So, that means, in today's class we saw what are the factors that affect erosion. Just to repeat: CTVS, climate, topography, vegetation and soil. These are the four factors that impact soil erosion, and then there are several ill effects of soil erosion that we have discussed, and in future lectures we will see how to control these ill effects. Thank you very much.